Okay, so we're going to look at matrix equations today. Matrix equations, when we get into the really big equations with multiple variables, more than 2, are going to be exciting. Today, it's going to seem like just an awkward way to solve a system of equations. It's not going to seem easier than what you've done before, but I promise by the time we're at the end of this unit and you have giant equations that you can solve, systems of equations, rather, it's going to make sense. So we have a system of equations here. 4x plus 6y equals 1. 3x plus 7y equals -2. And what we do is we're going to break apart the coefficients from the variables. So the coefficients of x and y become their own matrix. So you make a matrix and you just take the numbers. I'm going to have 4, 6, 3, and 7. And that makes a square matrix. So those are just the numbers that were in front of x and y. But we can't just completely get rid of x and y. So somebody somewhere went, wait, if we make a column matrix with x and y like this, if you multiplied them, that would be 4x plus 6y. But we just broke it apart so that we can solve for x and y. And then this equals the matrix with the constants on the other side. So 1 and -2. So your first skill is, can you take a system of equations and make it into a matrix equation? It's pretty straightforward.
Whoa.
So this matrix comes from the coefficients. This one has your variables. They go vertically. Do the equals, and these two make a matrix here.
Oh, never mind.
And then I will give you the rules for how we're going to solve it. And this is more exciting when you have W, X, Y, Z, or A, B, C, D. But we're going to start with the smaller ones just because the math gets involved. Okay, so we're going to talk about how you solve normal equations, rearrange normal equations. So here's a linear equation, AX equals B. Our directions say solve for X. How do I solve for X if it's multiplied by A? How do I get rid of the A?
Divide by X.
Divide by maybe A and leave X there.
We're trying to solve for A.
We're trying to solve for X. Did I say
I think so.
I'm sorry. So I meant solve for X because it says solve for X. So now I get X equals B divided by A. We talked in the previous lesson that we don't have matrix division. So over here, this matrix equation, if I was to label it, I would call this AX equals B. You use capital letters to represent your matrices. So this is the setup that we're looking at over here. We do not have division. I can't divide by a matrix, but we do have inverse matrices, which is essentially the equivalent with matrices. So what you do to get rid of the A is you multiply by A inverse. So that's little A -1 times AX, and then over here you have A inverse times B. Now it's important that the A inverse is in front on both sides. Okay? Because if I switch B and A inverse, it doesn't work. It is a -1. That means the inverse of A. What that does is that cancels out this A and leaves you with X. And then it's A inverse times B. So if I'm trying to solve for all of the variables, that matrix with the variables in it, I find the inverse of the coefficient matrix and then multiply it by the constant matrix. It'll make more sense when we get into the numbers. But this just explains we don't really have division like you do in normal equations, so we use the inverse. That's our equivalent thing for matrices. All right. So
there's a lot of paper tearing I'm hearing.
I know. All right, so solve the following system using matrices. There's a lot of writing here that you're going to want to put on your paper because this is involved. So if we set this up as matrix equations, also you want to write small. So you do the coefficients. I will have 2, -3, 5, -2. My variables are x and y, and they go x and y from left to right. So I'm going to flip that around and make it go up and down. And that's so that if you multiplied them out, it would be 2x and -3y. But we separated them so we can solve for x and y.
Yeah.
And then over here it equals -11, 0. All right? So this is matrix A. They call this matrix X, and this is matrix B.
So we're just rewriting everything in the equation in matrix form?
In matrix form so that we can solve for X and Y.
Okay.
So what we're going to do, X equals A inverse, the inverse of A, times B. So we need to find the inverse of this matrix and multiply it by this matrix. So both are things we've done. We did inverses yesterday, multiplied matrices in the previous lessons before that. So we just have to get that all done. So we'll do the determinant of A first. So 2 times negative 2 is negative 4 minus negative 3 times 5 is negative 15. So this will become negative 4 plus 15, which gives me 11. So my A inverse is going to be 1/11th, and then I have to do stuff in here. So I switch the 2 and the negative 2, which is going to make it look like I just changed the signs, but you actually want to switch them. And then the negative 3 and 5 change signs. So you get positive 3, negative 5. And then you distribute the 1/11th. So basically, since it's 1, each of these numbers just becomes the numerator of the fraction with 11 on the bottom. So I'm going to get negative 2/11ths, 3/11ths, negative 5/11ths, and 2/11ths. So that's the inverse of A. And then what I need to do is multiply that by negative 11, 0. So for the sake of space, what I'm going to do is just take this and write it over here because I'm running out of room. So you find the inverse of this matrix, the square matrix, and then we're going to multiply it by negative 11, 0. And on the ones that I'm going to do with you guys, you're going to end up with whole numbers. The fractions will go away.
Okay, but wait, is this going to come up?
It's going to give us X and Y.
Yeah, it's going to be
2 numbers. So this is a 2 by 2, and that's a 2 by 1, and our answer is going to end up being a 2 by 1. So,
This is a lot of crazy stuff.
yep. So we're going to take negative 2/11ths times negative 11. So the negatives cancel, the 11s cancel, and you're going to end up with just 2.
yeah.
And then when I take 3/11ths times 0, that's just 0. So I don't feel like putting plus 0. I'm going to skip that part.
And then it's going to be 3 for the.
That's a 5.
Well.
So negative 5/11ths.
The 0. Yeah.
So that's 0. So this would give me 5, because the 11s would cancel. Negative 5/11ths times 11 is 5. And then 2/11ths times 0 is just 0. So this is my answer. And basically this gives you X and Y. If you were thinking about this in graphing terms, you would write the point 25 like this. That's what it actually represents. X is 2 and Y is 5. So it's just a process to solve systems of equations. Now, I know you're thinking this is not easier than the elimination method we did last year. It's not. Unless, think about this, if you had a 3 by 3 matrix or a 4 by 4 matrix, we haven't even done how to do those I guess we did determinants for the bigger matrices, but it's just a bigger pain in the butt to solve them by hand. The matrices are better, more efficient. And we're going to teach you guys some tips and tricks when we get to those bigger ones. We're going to do these by hand, just so you understand the process. All right? So let's go on to the next one. So we could shorten this down a little bit to save some space. Just go, okay, A is the matrix, negative 3, 2, negative 5, 3. And we can go, okay, B is the matrix 1, 2, and we're just trying to do A inverse times B. That's basically what you have to get out of this. I wanted to show you all of the steps so you understand where it's coming from. We've sort of proven that this works. But now we're going to do this. So we have to find the inverse of A. So I'm going to do that down here.
No.
So the determinant will take negative 3. Actually, I'll do that over here. Negative 3 times 3 is negative 9 minus negative 5 times 2 is negative 10. So we get 1.
Everyone takes all this stuff.
Okay, so A inverse, we're going to have 1 over 1. If the determinant is 1, that's cool because basically we're just going to multiply everything by 1. So once I rearrange everything, this will be easy. So we're going to switch these two numbers. So the positive 3 goes here, negative 3 goes there. And then we're going to change the signs on these. So negative 2 and positive 5. And then we're just multiplying through by 1. So that's basically your answer. So that's what I need to use. I need to take 3, negative 2, 5, negative 3, and multiply it by 1, 2. We don't have any fractions this time. And whatever we get is going to give us the value for x and y. So 3 times 1 is 3. Negative 2 times 2 is negative 4. So 3 plus negative 4 gives us negative 1. And if you still need to write that out, it's okay. I'm just running out of room. And 5 times 1 is 5. Negative 3 times 2 is negative 6. So 5 and negative 6 together make negative 1. So basically this gives us x and y. And if we wanted to write the answer in point form, it would be negative 1 would be your actual solution. And you can check to see that this is the right solution, just like we did when we solved systems equations before. You can put that in for x and y and make sure it comes out 1, make sure it comes out 2. So you would check these just by putting the numbers back into the equations.
Doing over there, Riley?
Okay, so we're going to do one more. And then practice problem. So hope we're all paying attention. All right. So A, matrix A is the coefficient matrix. So we're going to have 9, negative 2, negative 4, negative 8 is matrix A. Matrix B is 51 and 4. So what we need to do is the inverse of A times B. So we've got to figure out that inverse first.
Not ready.
And since we have this space over here to the side, I'm going to use that to do the inverse. So if we do the determinant of this matrix, I would get negative 72 minus positive 8, which gives me negative 80. So my determinant, or I'm sorry, yeah, so 1 over the determinant. And then we switch the 9 and the negative 8. We're not switching signs, they are switching places. So the negative 8 goes here, the 9 goes there. And then we change the signs on the negative 2 and negative 4 to make them positive 2 and positive 4. And we will go ahead and multiply this out.
Ah, no, I drew a line.
Okay, so negative 1/80th times negative 8 is 8/80ths. And I'm just going to leave it like that. I'm not going to reduce it for a minute. And then 2 times negative 1/80th is negative 2/80ths. I'm going to have negative 4/80ths and negative 9/80ths. So it looks crazy to have the 80ths and to not reduce, but if you actually don't reduce them, that helps you when you multiply, because then everything already will have common denominators. So that's a tip you might want to put in your notes.
Ethan started a war.
Do not
No, I didn't.
reduce at this step. Shh. So don't reduce at this step, because when you go to multiply them and you're adding stuff, you want it to have common denominators anyway. So we're just going to leave it like that. So my A inverse is 8/80ths, negative 2/80ths, negative 4/80ths, and negative 9/80ths. So I'm just rewriting it over here under where I had this formula.
You said underwear.
I said under the formula, and I'm going to take it times 51 and 4.
Okay, why did I get looked at? Obviously, I didn't shoot it myself.
All right, so shh. We're going to finish this up, and you guys hopefully will know what you're doing. All right, so if I take 8 times 51, that is 408/80ths. And then if I take negative 2/80ths times 4, that'll be minus 8/80ths. And what that's going to end up being is 400/80ths. So I'm going to write that down here so I can show the steps. 400/80ths reduces to 5. So you do want to reduce down here. So on the final answer, reduce that, reduce the answers. Okay, come back up here, do the other one. Negative 4/80ths times 51, negative 4 times 51 is negative 104/80ths. Negative 9 times 4 is negative 36/80ths. So negative 104 and negative 36 is negative 240/80ths. So think
Okay, now
24
I'm
divided by 80. So that's negative 3. So that means x is 5, y is negative 3. So my answer is actually 5, negative 3, the point, if we were to graph these.
Okay, now
So the
that's
fractions
a whole lot.
are involved.
Too much, that's too much.
Yeah.
It's not too much. You just have to. So basically on all of these, just keep the same denominators all the way through so that you have common denominators. I was just subtracting the numerators. They're assuming you guys have fraction skills.
No, like I know how to do it. It's just so much numberage.
But keep in mind that this is going to make something else later on easier.
What